Hi everyone, welcome to Go Classes. Please let me know, is the audio video is everything fine? Audio video volume. So in this session we will discuss scholarship test solutions. So today on 7th August we had a scholarship test for Go Classes GATE 2023 complete course, and now we will see the solutions of this scholarship test. So I will only discuss the discrete mathematics questions solutions. Okay. And tomorrow we will also discuss C programming question solution, that we will discuss tomorrow. Okay, so today we will discuss all the discrete mathematics questions in this scholarship test. Okay, so let's start now. So how did you find this scholarship test? How are the questions? The questions, I think the questions were very good. All the questions were original questions. Okay, analytical questions. See, the questions were not hard, the questions were analytical. So if you have good understanding of concepts, then you can solve the questions. And let me tell you one more thing, that time, we intentionally kept less time for the questions. So some of you might be thinking that 20 minutes more should be there. Yes or no? Okay, so but remember that we intentionally kept less time, because some students, they do cheating. Okay, so we did not want to we did not want those students to succeed who are doing cheating. Okay, so that is the reason we kept less time. Okay, anyway, so let's start now. Before starting, let me just, okay, so this is our Go Classes YouTube channel. On the you can subscribe to this Go Classes YouTube channel, and there will be many important sessions related to GATE computer science, related to computer science on this Go Classes YouTube channel. Now let's start now. So let's see the first question. Okay, this is your question number 1 in the scholarship test. Let's see. So the question is asking, a relation R is defined on a set, and we are saying that a relation is called total relation if and only if A is related to B, or B is related to A, or both. Okay, so for every A comma B, means in this set, on this set we are defining a relation, and we are saying that for any two elements, remember those elements can be same or different, whatever two elements you take. Okay, basically A comma B belongs to A. What it means? It means that these A comma B, they can be same or different, because these two elements, they belong to A. So what we are saying that a relation is total relation if and only if whatever two elements you take, same or different, at least one of them is related to another. Okay, either A is related to B, or B is related to A, or both. Now the question is asking which of the following is false. So let's solve this. So first of all, this total relation, first you understand this total relation, that this base set A is given to you. So this base set is A. In this base set, let us assume that these are the elements. Let's assume these are the elements A comma B comma C. Now we are saying that we are defining a relation R. This relation R we are defining on this set. Remember, these are the elements, and we are defining the relation on this set. So what this relation will do? This relation will relate elements of A to elements of A. This is what this relation will do, correct? So elements of A will be related to elements of A, and we are saying that this relation R is a total relation. This relation we are defining on A, and we are saying that this relation R is total relation. When can I say this is total? When can I say this is total relation? This will be total relation if and only if for all A comma B, means okay, for all X comma Y in A, in this set A, because this is our base set, on this set we are defining the relation. So whatever two elements you take in this set, same or different, for all X comma Y belonging to A, I can say that either X is related to Y, or Y is related to X, or both of them. Okay, this is the inclusive OR. This is the inclusive OR. This is the inclusive OR. So this is the definition of total relation. So tell me one thing, can I say total relation will be reflexive? This is my first question. Can I say that total relation will definitely be reflexive? Can I say every total relation is reflexive? Is reflexive? Can I say? Can I say this is definitely reflexive? Yes, it will be reflexive, because if you take same elements, if you take x comma y, if you make them same, if x comma y both of them, if you make them same, then what will happen? Then they will be related to, okay, that will be related to itself. So I can say that a is related to a, I can say b is related to b, and I can say c is related to c. So you can notice total relation is definitely reflexive, correct? Yes or no? Because you can notice that whatever two elements you take for all x comma y in this base set, so these elements can be same or these elements can be different. What should happen? That at least one of them should be related to another. Okay, now total relation is definitely reflexive, because if you take the same elements, if you take x comma y, if you take them same, for example, if you take x as a and if you take y as a, then a is related to a, b is related to b, c is related to c. So I can say yes, so this is correct, I can say that this is correct. So definitely total relation is reflexive. Okay, every total relation is reflexive. So this statement is true, but what the question is asking, remember the question is asking which statement is false. Okay, so this statement is not our answer. This statement is true, but this statement is not our answer, because the question is asking false. Now let's see what the second option is asking. You have total relation and it is symmetric, then can I say it will be equivalence relation? You have total relation and it is symmetric. So this is the second option, that if you have total plus symmetric, then what can you say? If your relation is total plus symmetric, then tell me what can you say about the relation? Remember, this total relation is saying that already it is reflexive. You already know that total implies reflexive. So already it is reflexive. So reflexive property is already there. Now, so this type of pairs x comma y, x comma x, this type of pairs we have in the relation. Okay, this type of pairs are already in the relation. Now, in this total relation, you can notice that if you take any two elements, if you take any two different elements, let's assume you take two different elements. Okay, if you have take two different elements, then what will happen? Then this total relation is saying that either a is related to b or b is related to a. At least one of them will be related to another. Okay, either a will be related to a, either a will be related to b, or b will be related to a. So at least one of them will be related to another. And you can notice that there is symmetric property also. So if at least one of them is related to another, then because of symmetric property, what will happen? Tell me. What will happen? Tell me. Total plus symmetric. This total is saying that whatever two elements you take, same or different, at least one of them will be related to another. At least one of them, either a or b, either a is related to b or b is related to a. Okay, or both, or both. Now, if you have symmetric property, then what will happen? Then I can say that definitely they will be related to each other. I can say a will be related to b and b will be related to a, whatever two elements you take. Okay, for all a comma b, a is related to b, b is related to a. So what is this relation? Tell me, what is this relation? Finally, remember total plus symmetric. This relation R on set A, and this relation R is total plus symmetric. So what can you say about this relation? What can you say about this relation, total plus symmetric? Total plus symmetric, what this is saying? This is saying that total plus symmetric, this is saying that for all a comma b belonging to a, means whatever two elements you take, what will happen? A will be related to b and b will be related to a. So every element is related to every element. What is this relation? Every element is related to every element. Then what is this relation? Then this relation is definitely, then so I can say, then this relation is definitely your cross product. I can say this is your cross product. This is the relation. This is Cartesian product A cross A, because in this A cross A, every element of A is related to every element of A. So you can notice total plus symmetric. What that means? That means every element of A will be related to every element of A. So I can say this type of relation, total plus symmetric, this type of relation, it means that your relation is A cross A. Your relation is, this is the relation. So finally, and you can notice this relation, if you notice, this is the equivalence relation, because every pair is there. Every pair is there. Okay, every pair we have. So this is a equivalence relation. Is this clear to everyone? Anyone has any doubt in this? Let me know. Okay, so quite simple. So definitely this is equivalence relation. Tell me one thing. So this is a equivalence relation, that is fine. So this statement is also true. This statement is also true. Tell me one thing. If I ask you how many total plus symmetric relations are there, if I ask you this question, that let's assume you are defining a relation on set A. Now my question is how many relations are there which are total plus symmetric? Tell me. If I ask you this question, how many total plus symmetric relations are there? How many total plus symmetric relations are there? And the answer will be what? Answer will be only one, because total plus symmetric, that means that your relation is A cross A. Your relation is A cross A. It means this is the only relation which is total plus symmetric. This is the only relation. So answer will be 1. This will be your answer. Okay. This is not total order. This is total relation. This is okay. Please understand, the question is not asking about total order. The question, this is the definition given for total relation. In the question, total relation, a new relation is defined. Total relation is defined. A new relation, this is defined. A new type of relation is defined. A new relation definition is given to you. A new relation definition is given. The question is not talking about total order relation. Total order relation, that is different. Total order relation, which is TOSET, total order set, this is different. These two are not same. This is a partial order. This is a partial order. This is a partial order plus, I can say this is a partial order plus remember, this is a partial order plus every two elements comparable. Okay, every two elements comparable for all A comma B. Either A is related to B or B is related to A. Okay, this is the question. This is the idea. So please understand that. So can anyone tell me, how can I say what is a total order relation? Total order relation is basically, I can say that it is reflexive, anti-symmetric, transitive plus total. This is the definition of total. This is the definition of total. This means total. This means total relation. This definition is given to you. This is the total relation. And what is partial order? Partial order means reflexive plus anti-symmetric plus transitive plus total. That is your total order relation. Tell me, is this clear to everyone? Is this clear? What is a total order relation? This total order relation, what is that? What is total order relation? Total order relation means partial order plus every two elements are comparable. Partial order means reflexive plus anti-symmetric. It should be reflexive, it should be anti-symmetric, it should be transitive. So this is the partial order. This is the partial order, and this is the partial order plus every two elements must be comparable. Every two elements for all A comma B, every two elements must be comparable. Either A is related to B or B is related to A. Every two elements must be comparable. So what can I say about this total order? This is the definition of total relation. In the question, this is the definition of total relation. So finally, I can say total order is equal to these properties plus total. I can say total plus partial order. I can say this is total plus partial order. Anyone has any doubt? Let me know. Is this clear to everyone? Okay, so don't confuse. In the question, definition is given to you. In the GATE exam, they will ask you this type of questions. The definition is given to you in the question. So don't confuse. Okay, anyone has any doubt? Let me know. Okay, don't confuse this total relation with the total order relation. Is the difference clear? Total order relation means partial order plus every two elements must be comparable. Okay, so I can say partial order plus total relation. Okay, now let's see the option number 3. That is true or false? Tell me. Option number 3. Option C. That is true or false? So this is saying that if S is total and transitive, if relation is total and transitive, then it is equivalence relation. Is it true? Total and transitive. Can I say total plus transitive? This option number C. Tell me, if relation R on set A, relation R on set A. If this is total plus transitive, can I say total plus transitive implies a remember already total implies reflexive, so we have reflexive, and this transitive implies transitive, so we have transitive also. Okay, so we have transitive also. But now the question is, do they imply symmetric? Tell me, do they imply symmetric? Do they imply symmetric? Tell me. And the answer is clearly, answer is no. No, you can very easily create a counterexample. You can very easily create a counterexample, and that is like this. You can take A comma B, okay, and you can define this relation. Look at this relation. A is related to A, B is related to A, okay, A is related to A, B is related to B, and A is related to B. Is this transitive? Tell me, is this relation transitive? You can notice this is transitive, this is total also, because whatever two elements you take, so this is total also, and this is transitive also. This relation is transitive also. Okay, if you notice this relation, the graph of this relation is like this. A is related to B, A is related to A, B is related to B. So you can notice that this is not symmetric. This is not symmetric. So you can say that this option number C, that is wrong. Yes or no? So total plus transitive, that does not imply symmetric. Remember, total implies reflexive, and this transitive implies transitive. This transitive implies transitive. But total plus transitive, that does not imply symmetric. So finally I can say this statement is false. This statement, I can say this statement is false, and the question is asking false, so this statement is correct. Option C. Let's see the next. The number of total relations. How many total relations on 5 elements? How many total relations on 5 elements? So number of total relations. So remember, very simple point, that in a total relation what will happen? If you make the matrix, like A1, A2, A3, A4, A5, if you make the matrix, let me take for example maybe 4 elements. Let me take 4 elements A1, A2, A3, A4. Now in this situation, definitely this will be true, this will be true, this will be true, this will be true. These will be 1 1 1. These entries will be 1 1 1. Okay, I can say that these entries will be 1 1 1 1. These diagonal entries will be 1 1 1. Okay, now tell me, what can you say about this A1 related to A2, A2 related to A1? What can you say about these? How many choices for these two pairs? For these two pairs, how many choices we have? Tell me. For these two pairs, how many choices we have? Remember, at least one of them must be related to another. A2 is related to A1, or A1 is related to A2, or both. So there are 3 choices. There are 3 choices. Yes or no? What are the 3 choices? Either A1 is related to A2, or A2 is related to A1, or both. Okay, either this is related to, either A1 is related to A2, but A2 is not related to A1. So these are the 3 choices. 3 choices are these. Okay, what are the 3 choices? A1 related to A2, but A2 not related to A1. Another choice, A2 related to A1, but A1 not related to A2. And another choice, that both A1 related to A2 and A2 related to A1. So there are 3 choices for every pair, whatever pair you take. Okay, for example, if I take like A1 related to A, like I can say that like A2 related to A3, this is A2 related to A3, and this is A3 related to A2. And tell me, how many choices for this pair? For this pair, how many choices for this pair? Again 3 choices. Again 3 choices. Either either A3 is related to A2, or A2 is related to A3, or both. Okay, so again there are 3 choices. So I can say that like this. So this diagonal, this is 1. All the entries on diagonal, this is 1. And you can notice for these pairs, okay, for these pairs, 3 choices you have. So tell me, what will be the answer? Total how many entries you have? If you have n elements, if you have n elements, then how many entries will be there? If you have n elements, let's assume you are defining a total relation R. You are defining a total relation R on set A. Let's assume set A has n elements. If set A has n elements, then how many entries will be there in the matrix? So in the matrix, how many entries will be there? In the matrix, there will be n square entries. There will be n square cells. and in these n square cells, n cells are one diagonal, all the diagonal n cells, all the diagonal n cells, these are fixed, these are one. Okay, these are fixed, these are one. Okay, and the remaining cells, if you notice, the remaining cells, if you notice, I can say the remaining cells, how many remaining? How many remaining cells are there? Remaining is n square minus n cells. Remaining are these n square minus n cells. But you can notice that in these remaining, for this pair of cells, for pair of cells, we have three choices. For pair of cells, we have three choices. So I can say how many pairs are there? How many pairs? Symmetric pairs. How many symmetric pairs are there? These many symmetric pairs. And for every pair, you have three choices. You have three choices for every pair. How many symmetric pairs are there? So total, how many symmetric pairs are there? These many symmetric pairs are there, n square minus n divided by 2. And for every symmetric pair, there are three choices. So finally, what is the number of total relations? That will be 3 power n square minus n by 2. This will be the answer. Okay, so remember, total number of total relations. What that will be? Number of total relations on set A, such that set A cardinality is n, set A has n elements, then number of total relations, that will be 3 power n square minus n by 2. This will be the answer. Okay, is this clear to everyone? Anyone has any doubt in this? Very simple. So the question is saying if n equal to 5, if n equal to 5, then answer will be n square 3 power. If n equal to 5, that will be 3 power 10. This will be your answer. Okay, and so answer will be 3 power 10. So this option is also wrong. This option is also false. And the question is asking false. So answer will be C, D. Okay, the answer will be C, D. Let me know. Did you got it correct in the exam? Is there anyone who got it correct? Answer will be C, D. In the exam, did you got it correct? Did you get it correct in the exam? Let me know. Did you understand now? Did you get it correct in the exam? And also, did you understand now? Vishal, did you understand now? Now can you say that you understood everything? This question, did you understand? Yuvraj, did you understand now? Remember, the only thing you have to do is improvement. Okay, basically constant improvement. Don't worry. In the exam, if you did it correct or if you did it wrong, don't worry about it. Okay, because remember, those students will succeed who consistently improve. Those students will succeed who consistently keep learning. Okay, so if you keep learning, then you will definitely succeed. So did you understand now? Okay, now let's see this question number 2. Let's see, this is another very nice question, and the question is saying that this S is a set of all 7-bit binary string. Okay, 7 bit strings, 7 length bit strings. So this in this set S, what is this set S? This set S has all the 7 length. I can say this is set of 7 length bit strings. 7 length bit strings. Okay, this is a 7 length bit string. Next, now the question is saying that we define a relation on set S by the rule. This rule is given to you. Now we are defining a relation, we are defining on set S, and we are saying that X is related to Y if and only if X and Y differ in exactly 1 bit position. Means if you have two elements of S, if you have two 7-bit string, like this is a 7-bit string, this is a 7-bit string. Basically the idea is like this. If you take two elements of this S, for example, let's assume that you take these elements, 7-bit string, 7 length bit string. So let's assume this is X and let's assume this is Y. Then tell me, are they related? Can I say, now we are defining a relation R on S. We are defining a relation R on S, and we are saying that X is related to Y if and only if they differ in only 1 bit position. X is related to Y if and only if they differ, X comma Y differ in only 1 bit position. Differ in only 1 bit position, in only 1 bit, in exactly 1 bit position. So can I say that X is related to Y? Can I say X is related to Y? Of course, because they are differing in only 1 bit position. And you can notice Y also related to X. So this definition is given to you that if you have 7 length bit string, then x is related to y if and only if they differ in exactly one position. They differ in exactly one position. Okay, is this question clear? Now the question is asking, what is the cardinality of relation R? What is the cardinality of relation R? So let me explain this question by taking a small, let us assume this as, let's assume this set as, this is set of 2 length bit strings. Let's assume this is set of 2 length bit strings. Let's understand this question. So let's assume this is set of 2 length bit strings. So if this set S, if this is a set of 2 length bit strings, means 0 0 0 1 1 0 1 1, then tell me what will happen in R. In relation R, we are defining a relation R on set S. Remember, we are defining a relation R on set S. What this means? We are defining a relation R on set S. What this means? This means this relation R is from set A to set A. Elements of A are related to elements of A, or I can say this R is subset of A cross A. Okay, this is the definition of relation. Whenever you define a relation on set A, then it means this relation is subset of A cross A. Now tell me what will happen. So what will be the pairs? You can notice this 0 0 will be related to 0 1. You can also see 0 1 will be related to 0 0. See, 0 0 will be related to 0 1 and 0 1 will be related to 0 0. 0 0 will be related to 1 0 and 1 0 will be related to 0 0, because they are differing in only one bit position. They are differing in only one bit position. Okay, yes or no? So next, you can notice that 0 0 1 is related to 1 1 and 1 1 is related to 0 1. Similarly, 1 0 is related to 1 1 and 1 1 is related to 1 0. So what is the cardinality of R? So tell me, what is the cardinality of R? Tell me. This is your relation. So the relation is basically this. This is the relation. So what is the cardinality of relation R? You can clearly see that is 8. Okay, that is 8. So now actually what is happening? So when you see this word that, okay, two things are related, x is related to y if and only if they differ in only one bit position. So when you see this word, what will come to your mind? They differ in only one bit position. They differ in only one bit position. So what will come to your mind when you see this? What will come to your mind when you see this? So yes, hypercube graph. Very good, very good. This is a hypercube graph. Basically it will happen, remember. So if your set has 2 length bit strings, if you take 2 length bit strings, then for this relation R, we are defining a relation R on set S, and we are saying that x is related to y if and only if they differ in only exactly one bit position. X comma y differ in exactly one bit position. In exactly one bit position. So what will be the graph of this relation R? The relation R, if you notice, what will be the graph of this relation R? The graph of this relation R. This will be a hypercube graph. But tell me, it will be directed or undirected? It will be directed or undirected? This will be a directed graph. Okay, because remember, this relation is a directed graph. Relation will give you a directed graph. So if you make the graph, it will become like this: 0 0 0 1 1 0 1 1. If you make the graph, then you will get a directed graph. This directed graph you will get 0 0. This is related to this. This is related to this. Remember, they are related to each other. It will happen like this. This is related to this. This is related to this. You can notice this is related to this. This is related to this. But you can notice one thing. What you can notice that? So tell me, can I say that what is the cardinality of R? Can I say 4? Can I say cardinality of relation is 4? Can I say, because every edge is a pair. Remember, every edge, what every edge is telling you? What this edge is telling you? This edge is telling you that 0 0 is related to 1 0. This edge is also telling you 1 0 is related to 0 0. Okay, so this edge is telling you that 0 0 related to 1 0, 1 0 related to 0 0. This edge is telling you 0 0 1 is related to 1 1. This edge is telling you 0 1 related to 1 1 and 1 1 related to 0 1. So every edge is giving you two pairs. Can you notice every edge is giving you two pairs? So the answer will be what? Every edge is giving you two pairs. You can notice every edge is giving you two pairs. Is it clear? Every edge is giving you two pairs. So what will be the cardinality of R? That will be 8. That will be twice the number of edges. That will be twice the number of edges. Okay? Clear? That will be twice the number of edges. So now tell me the answer. When you have this 7 length bit strings, so tell me the answer. When you have 7 length bit strings, so for 7 length bit strings, what will be the answer? So very simple. Basically, the answer is this. Remember, if you have n length bit string, okay, let's find out the answer for n length bit string. So let us assume your set has n length bit strings. This is a set of n length bit strings. Let's assume. So if this has n length bit strings, this has n length bit strings. Basically, this I can say this set is what? This is a set of n length bit strings. This is the set n length bit string. Every bit string is a n length, means this has n length bit strings. Okay, like this type of strings you have. So this type of strings n length. Okay, and so on. So n length bit strings. So in this is your set. Now on this set, tell me what is the cardinality of this set. So there will be total how many strings of n length? That will be 2 power n. Now we are defining a relation R on this set S. We are defining a relation R on this set S. And what is the graph of this relation R? What will be the graph of this relation R? The graph of R. What can I say about graph of R? The graph of this relation R, that will be hypercube. That will be a hypercube graph. So what can I say? That will be hypercube graph. That will be Qn. That will be Qn. Okay, so that will be Qn. Like here you can notice for this, the relation, this graph, if you notice this graph, I can say this is Q2. So similarly here, you will get the graph Qn. And you can notice in this Qn, every edge, okay, in this Qn, what is the number of edges in Qn? Tell me. What is the number of edges in Qn? In this hypercube graph, what is the number of edges? We already know what is the number of edges. That is n multiplied by 2 power n minus 1. Okay. How to find out? How to find out? Very easy to find out. Remember, in this Qn, you can notice this is a hypercube graph. What is the degree of every vertex? What is degree of every vertex? Like what can I say about degree of every vertex? Tell me. In this Qn, this is a hypercube graph on 2 power n vertices. In this Qn, number of vertices is 2 power n. That is 2 power n. So what is the degree? What is the degree of every vertex? That is n. So what is the total degree? What is the total degree? Total degree is twice the number of edges. Total degree is what? Every vertex has degree n, and there are 2 power n vertices. So that will be twice the number of edges. So number of edges will be what? That will be number of edges will be n multiplied by 2 power n minus 1. This will be the number of edges. So number of edges in hypercube graph. Remember in this Qn, number of vertices is 2 power n and number of edges will be n into 2 power n, n into 2 power n minus 1. And this is the proof. This is the proof because remember the degree of every vertex in this Qn, in this hypercube graph on 2 power n vertices, the degree of every vertex is n. So the total degree will be n into 2 power n because every vertex has degree n and there are 2 power n vertices. So this total degree is equal to twice the number of edges. So number of edges will be n into 2 power n minus 1. Okay. So from here you can notice. Now tell me what will be the cardinality of relation R? The cardinality of relation R, that will be twice the number of edges in Qn. That will be twice the number of edges in Qn. Correct? So that will be twice the number of edges in Qn. So the answer will be what? That will be 2n. Okay, so I can say that will be n into 2 power n. In this relation, the cardinality of this relation will be n into 2 power n. Because remember why? Why? What is the reason? The reason is every edge gives you two pairs. Every edge gives two pairs. Every edge gives two pairs. Two ordered pairs. Every edge gives two ordered pairs in R. Okay. Let me know. Is this clear? Every edge will give you two ordered pairs. Every edge will give you two ordered pairs in R. So finally, number of this cardinality of R will be n into 2 power n. So if the value of n, if I take value of n is 7, this is given in the question. So the cardinality of relation that will be n multiplied by 2 power n. So that will be n into 2 power n. 7 into 2 power 7. So that will be 7 into 128. Okay, can you calculate what is this value? I think this will be 896. You can calculate. What is this value? Can you calculate? Okay, so the answer will be 128 multiplied by 7. The answer will be 896. So this question, did you understand now? How many of you got it correct? How many of you got it correct? The answer will be 896. Did you get it correct? Which mistake did you make? Did you make, okay, see, this is the mistake. This is the most common mistake students will make, that they will just find out number of edges. Okay, many of you might have gotten this answer. I think many of you have got this answer, like half of this. Yes or no? Many of you have got this answer. But this is wrong. Okay? This is wrong. Yuvraj, very good. So Yuvraj has applied bipartite graph, because hypercube graph is bipartite graph. This QN, this hypercube graph, this is also bipartite graph, we already know. This QN is a bipartite graph, that we already know. Every hypercube graph is a bipartite graph. So Yuvraj, can you write your answer on the GATEOverflow website? Yuvraj, if you are solving the question by a different approach, then you should answer on the GATEOverflow website. Okay, just go to the GATEOverflow website. On this question, you can write your answer. Okay, so write your answer on this question. Did you understand now? Please tell me. Please tell me, did you understand this question? Very nice question, very simple question. This question is connecting. This is a very nice question. This question is connecting graph theory with relations. Basically, the graph theory with relations. Okay, this question is connecting. And remember, we can connect graph theory with relations many times. We can connect. Okay, so we can connect because every relation we can represent as a graph. Okay, and we can think of every graph as a relation. So you can notice that this question is connecting relations with graph theory, and this is a nice question. Now let's move on. Now let's see this question. Question number 3. What will be the answer? This is another very nice question. The question is asking for partition. The question is asking for partition. So first of all, A, B are disjoint non-empty set. It is given to you that they are disjoint non-empty set. Okay, so in the question, what is given to you? That there is a set M, and there is a set A, and there is a set B. These are non-empty. These are non-empty disjoint set. A, B. These are non-empty disjoint sets. Okay, after that, M is the universal set. And what is saying? A union B is proper subset of M. Means there are some elements here. Means there are some elements here. Okay, A union B is proper subset of M. Means there are some elements here. Next, this is the definition of complement. S dash is the complement. Now the question is asking, which of the following is a partition of M? Which of the following set is a partition of M? Partition of M. So first you tell me, we have already seen what is partition of any set. Remember, this is the partition of any set. What is partition of any set? Partition of a set S. So let's assume you have a set S. Let me assume this is your set S. Then what is a partition? Partition means this set S you are dividing into this type of parts. This is called partition. This is called partition. This I can say this is part 1, part 2, part 3, part 4. This is called partition. So I can say this is a partition of S in which you have 4 parts. Part 1, part 2, part 3, part 4. Okay. So this is called partition. We call it partition. This is partition of S. And this is called part. and this is called part of this partition. Okay, now tell me, what are the properties of partition? Some properties are there, that these parts, they cannot be empty. These parts cannot be empty. This part, every part should be non-empty. What is the second property? They should be disjoint. They should be disjoint. They should be disjoint. Pi intersection Pj, they should be disjoint. Their intersection should be disjoint. Like you can notice, like this P1, please understand that you can notice that this P1, okay, this P1, this is disjoint from P2, this is disjoint from P3, this is disjoint from P4. So if you have any set, remember, if you have any set, let's assume you have any set S or any set, for example, let's assume you have any set A, then what is partition of A? Partition of A means you are dividing this A into disjoint non-empty parts. You are dividing this A into disjoint non-empty parts. Disjoint non-empty part. This is part 1, this is part 2, this is part 3, part 4, part 5, part 6. So disjoint non-empty subsets. So these are the properties. They should be non-empty, they should be disjoint. And what is the third property? What is the third property? The third property is their union must be equal to S. If you take their union must be equal to S. The union of all the Pi, that must be equal to S. So I can say, what is partition? What is partition of A? Partition of A, that is nothing but a set. Remember, partition of A, that is a collection. That is a collection of non-empty disjoint subsets. That is a collection of non-empty disjoint subsets. Disjoint subsets of A which cover all the elements of A. Okay, which cover all the elements of A. Which cover all elements of A. Which cover all elements of A. Okay, this is the definition of partition. Is this clear to everyone? Tell me. This is the definition of partition, you can notice. Okay, so partition of A, that means collection of non-empty disjoint subsets of A which cover all the elements of A. This is the definition of partition of A. Very simple. Okay, so now tell me the answer. So in the question, what is asking? So can I say this A comma B, is this a partition of M? The question is asking partition of M. Can I say this A comma B, is this partition of M? The first, can I say this A comma B, is this partition of M? No, this is not partition of M because it does not cover M. Okay, this is not a partition. Remember, this is non-empty disjoint. A comma B, these are non-empty, they are disjoint, but their union is not equal to M. A union B is not equal to M, because you can notice A union B is proper subset of M. A union B, that is proper subset of M. So you can notice A union B is not equal to M. Okay, so this is not a partition. This option A, this is not a partition. What about option B? A, B, A dash and B dash. A, B, A dash and B dash. What is this? So basically, remember what this area is. So you can notice this is A. This is A. Okay, this is your A. This is A. And this is B. And this is B. And where is? So where do we have this A complement and B complement? A complement and B complement means neither in A nor in B. Means neither in A nor in B. A complement and B complement. This area is the A complement B complement. Remember this area. This outer area. This area is A complement B complement. This area. Okay, I can say that this area is A complement and B complement. Now tell me, do they satisfy all the three properties? Are they non-empty? Yes, it is given in the question. It is given in the question that you have disjoint non-empty set. A is non-empty, B is non-empty. So you can notice, and A union B, that is subset of M, that is proper subset of M. So this is also non-empty, non-empty. So these are non-empty and they are disjoint and their union is equal to M. So yes, this is a partition. Yes or no? They are non-empty. A is non-empty, B is non-empty. This is also non-empty. They are non-empty, they are disjoint and their union is equal to M. So this is a partition of M. This second, this is a partition of M. What about third one? What about the third one? Let's see the third option, that is A union B. That is A union B, A union B, and A complement and B complement. Now you can notice that. So are they disjoint? Yes, definitely they are disjoint, this and this area. Because remember this, if you notice this area, this is your A union B, this is A union B. And if you notice this area, this outer area, if you notice, this is your, this outer area, this outer area is A complement and B complement. So they are disjoint. So you can notice they are disjoint, they are disjoint, they are non-empty, they are disjoint, they are non-empty, and their union is equal to M. And they are union, if you see their union, this union A dash and B dash, if you see, that is equal to M. So yes, this is also a partition. Is this clear? This option number 3, that is also a partition. This is also a partition. What about option number 4? Tell me now. Tell me quickly. A intersection B, A minus B, B minus A. What about this one? What about the fourth one? Tell me about the fourth one. Is this a partition? A intersection B, A minus B, B minus A, and A complement intersection B complement. So remember, because they are disjoint, because A comma B are disjoint, so A minus B is basically nothing but A. Because A comma B are disjoint, if you notice they are disjoint, they are disjoint. So because they are disjoint, so A minus B is equal to A, B minus A is equal to B. So if you notice, this is nothing but A. If you notice, this is actually nothing but A. I can say this is nothing but A. A intersection B, this is A, this is B, and this is A complement intersection B complement. Tell me, are they disjoint? All of them, are they disjoint? Yes, they are disjoint. Yes, they are disjoint. You can check. Yes, they are disjoint. Do they cover all the elements of M? Do they cover all the elements of M? Yes, they cover all the elements of M. They will cover all the elements of M. But you can notice this is not empty. This is empty. But you can notice this is empty because A comma B are disjoint. So because this is empty, so this is not a partition. This option number 4, this is not a partition because this is empty. This is empty. You can notice this is empty because they are disjoint. A comma B are disjoint. So this is empty. So this is not a partition. So the answer will be B comma C. Did you get it correct in the exam? In the scholarship test, did you get it correct? This question. This question did you get correct? Can anyone tell me one thing? Okay, please tell me one thing. Now, if you see the video solution, if you see the solution of all the 3 questions, we have seen solution of 3 questions. These questions are very analytical. Like, okay, are you thinking that these are hard? Very basic concepts we are using. We are using the definition of partition. We are using the definition of relation, definition of equivalence relation, definition of this partition, definition of this hypercube graph. All the questions are very analytical. These are not hard questions. These are not complicated questions. These are very basic. Okay. C programming, all the questions of C programming we will discuss tomorrow. C programming solutions we will discuss tomorrow. Okay. Now let's see this question number 4. Quickly tell me the answer. This is a very simple question. A grid is given to you. So this is a 3 by 11 rectangle grid. This is grid is given to you 3 by 11. Okay, the size is 3 by 11. There are 3 vertical steps and there are 11 horizontal steps. So you can notice there are 3 vertical steps. There are 3 vertical steps and there are 11 horizontal steps. 11 horizontal steps. Now the question is asking that you have to go from A to B. How many walks are there? How many staircase walks are there from A to B? Which start by going to the right 2 times. Which start by going to the right 2 times. Means you are starting by, okay, this. Basically, you are starting like this. Now you are here. You are starting like this. Remember, you are starting like this. So now you are here. Yes or no? Now you are here. Now from here you have to go to B. Okay, from here you have to go to B. Okay, from at this point, from this point you have to go to B. From this point. So from this point to B, how many horizontal steps you have to take and how many vertical steps you have to take? Tell me. From this point, to B, let me call it, let me call this point T. Let me call this point T. So tell me, from T to B, how many horizontal steps you have to take? From T to B, how many horizontal steps? You can clearly see that there will be 9 horizontal steps. 9 horizontal steps you have to take. You have to take 9 horizontal steps and you have to take 3 vertical steps. In any order you can take them. You have to take 9 horizontal steps and you have to take 3 vertical steps. These steps you can take in any order. These you can take in any order you can take. In any order you can take these steps in any order. So finally answer will be what? It's like I can say there are 9 H and there are 3 V's. Okay, so every permutation you have to count. You have to count every permutation. 9 horizontal step and 3 vertical step. Every permutation we have to count. So how many permutations are there? So what is the number of permutations? What is that? Number of permutations. 9 horizontal step, 3 vertical step. So the number of permutation, that will be 12 factorial divided by 9 factorial 3 factorial. The answer will be 12 factorial divided by 9 factorial 3 factorial. You can calculate, this will be your answer. So this is another very simple question. Yes or no? So the answer will be 12C3. Yes, the answer will be 12C3 or 12C9. You can write it 12C3 or you can write it 12C9. This is your answer. Very simple question. Okay, extremely simple question. But remember, we are starting by going to right 2 times. Means from this A you are going to T. Okay, and then from T you have to go to B. So our task is that we have to go from T to B. This is what we have to do. So 9 horizontal and 3 vertical steps we have to take. In any order you can take them. Every permutation. So how many permutation? That will be 12C3. Let's see this question. Did you do this? Another very simple question. What this question is asking, that there are 5 cards. Read the question. There are 5 cards. Each has a distinct value. So every card has distinct value. And there are 5 different. So basically there are 5 different values. Every card has a different value. We put them face down on the table. So these cards we are putting on the table face down. There are 5 players. And every player, to every player we give a number. To every player we give a number. Now, okay, every player has a different number. Remember, every player has a different number. Now what we are saying that to every player we give a card. There is a dealer who is giving to every player, he is giving a card. Now, a player will lose if the value of the given card is same as the value of that player, as the value that the player has. If no player will lose, then dealer will lose. So how many ways are there such that dealer will lose? Okay, did you understand this question? The question is actually very simple. What this question is saying, that there are 5 people. The question is saying that there are 5 people. Let me call them A, B, C, D. Okay, let me call them A, B, C, D, E. There are 5 people. So these are the 5 people. To every person, what we give a number. To every person we give a number. Let us assume these are the numbers that are given to him. Like, okay, let's assume this number A is given to A, this number B is given to B, this number C is given to C, this number D, and this number E. So every person has a different number. 5 people are there and every person has a different number. Every person has a different number, A, B, C, D, E. Now what we are doing, we are giving one card to every, okay, like one card we are giving to A, one card we are giving to B, one card, okay, to this, one card to this, one card to this. When the dealer will lose, when no player will lose. Okay, means A should not lose. Tell me, if A is not losing, then what should be the card value to A? Can anyone tell me? If A is not losing, then what should be the card value to this A? Remember, every person has a value. Every person has a value. For example, let's assume this has value 5, this has value 2, this has value 3, this has value 6, and this has value 4. So every person has a value. Now, if A is not losing, then what should be the value of, remember, if you give Remember, if you give 5 to A, if you give this value 5 to A, if you give this 5 value card, if you give this 5 value card to A, then A will lose. Yes or no? Then A loses. Then A will lose. So, okay, then A will lose. If you give this number 5 value card, if you give this card to A, then A will lose. So A should not have 5. I can say A should not have 5. So you should not have 5 here. Similarly, you should not have 2 here. You should not have 3 here. You should not have 6 here. You should not have 4 here. Okay. So what is this problem? Can anyone tell me? Like, what is this problem? This is a derangement problem. Yes or no? It's like this. It is a derangement problem. You are not having the value of your value. Like, let's assume I have this value. These are the values. Let's assume these are the values. This is a derangement problem. What it means? Here you should not have 1. Here you should not have 2. Here you should not have 3. Here you should not have 4. Here you should not have 5. This situation is derangement situation. Can you notice this is the derangement situation? This is your derangement problem. No one should be in their home. Okay, no one has their value. No one in their no one in their position. No one is in their position. No one is in their position. So this is a derangement problem. So the answer will be what? This is a derangement problem because remember, okay, for example, this person cannot have value 1, this person cannot have value 2, this person cannot have value 3, this person cannot have value 4, this person cannot have value 5. So you can notice no one is in their position. No one is in their position. So this is a derangement problem of 5 elements. So I can say this is ultimately this is a derangement problem of 5 elements, and that is 44. Derangement problem of 5 elements, the answer will be 44. So the dealer will lose when derangement is there. Remember, dealer will lose when there is derangement. I can say dealer loses when the dealer will lose. Dealer loses when derangement. When there is derangement, then the dealer will lose. Okay. So here I can say how many ways are there that dealer will lose? The answer will be 44. There are 44 ways that dealer will lose. So you can notice this is a derangement problem. Did you understand? In the exam, did you do it correct? See, when you read this question, first you understand the question. So when you read this question, you can see that this is a derangement problem. Yes or no? So this is a very simple question. This is just a derangement problem, nothing else. You can see that no one is in their position. Okay. Next, let's see this question. What is the answer for this? Consider there are 3 boxes. Remember, there are 3 boxes and there are 12 balls of same size. Now, 3 indistinguishable red balls means 3 identical red balls and 9 different blue balls. And the question is saying the first box can have at most 3 balls, the second box can have at most 4 balls, the third box can fit at most 5 balls. Tell me, in this question, boxes are different or not? Boxes are different or not? Tell me. In this question, information is given. There are 3 identical red balls. So 3 same red balls. There are 3 identical red balls. So there are 3 identical red balls. There are 9 distinct blue balls. And there are 3 boxes. In this question, this information is not given that boxes are identical or different. Are they identical or different? How will you say that they are identical or different? These boxes. Tell me. Think about it. They are identical or different? Yes. So boxes are different. Boxes are different because their capacity is different. You can clearly see their capacity is different. You can see that first box can fit at most 3 balls, second box can fit at most 4 balls, and third box can fit at most 5 balls. So the boxes are also distinct. The boxes, their capacity is different, so they are distinct boxes. Now let's solve the question. We put the balls in boxes such that all the red balls go into the same box. All the red balls, they should go into the same box. What is the total number such that we can put the balls? Now this is a very simple question, that very simple question. All the red balls, they should go to the same box. All these red balls. So there are 3 red balls. I can say there are 3 red balls, RRR. This is not the movie. Okay, this is the 3 red balls. All the identical red balls, RRR. Okay, now tell me. So all the red balls should go into the same box. Either they can go into the first box, either they can go in the box B1, or they can go in box B2, or they can go in box B3. Box B1 has capacity of at most 3. This has capacity of at most 4. This has capacity of at most 5. This is the capacity. Now, so 3 cases I will have to consider. Yes or no? I will have to create 3 cases. These red balls, they should go into the same box. They should go into the same box. Now I have to create cases. What are the cases? What are the cases I have to create? They go in the box B1. They go in the box B2. I have to create cases. They go in the box B2, or they go in the box B3. So I have to create 3 cases I have to create. Yes or no? 3 cases I have to create. Now let's create the case. So when all the red balls, this is the case 1. This is the case 1, that all the red balls, they are going into B1. And remember, B1 has capacity of at most 3. Remember, B1 has capacity of at most 3. So can I put any blue ball in this? These 3 red balls I am putting in B1. Now B1 is full. Now this B1 is full. Now this B1 is full. It means the 9 blue balls. It means the 9 blue balls, they should go in B2 or B3. They should go in B2 or B3. So they should go in B2 or B3. Now tell me, is okay. So is how many possibilities are there? 9 blue balls should go to B2 or B3, but you can notice B2 has the capacity of 4, at most 4, and B3 has the capacity of at most 5. So if 9 balls are going into B2, B3, then what is the only possibility? What is the only possibility? The only possibility is B2 must have all the 4. B2 must be full with capacity. Okay, and B3 must have its full capacity, because you have 9 balls. Total 9 people are there. In this bus you can put at most 4 people. In this bus you can put at most 5 people. So there are total 9 people. Then what? There is no choice. There is no choice. You have to put 4 people here. You have to put 5 people here. You have to fill this bus completely. You have to fill this box completely. There is no other choice. Okay, because you can put at most 4 people you can put here, at most 5 people you can put here, but there are total 9 people. So we have to fill these boxes with their full capacity. Full capacity. Now tell me, so B2 must have 4 balls and B3 must have 5 balls. So tell me, and these are distinct. These blue balls are different. Okay, these blue balls are different, distinct. So you can notice that from the 9 you can select 4. From the 9 blue balls you can select 4 and you can give to B2. Okay, and the remaining will go. The remaining 5 you can give to B3. Okay, you can give to B3. So the answer will be, okay, in this case 1 has 9C4. So I can say in this case 1, what will you get? You will get 9C4. This is what you will get in case 1, 9C4. Now let's see case 2. Case 2 means all the red balls RRR. These we put in B2. Remember, these we put in B2. And how many? Okay, 2 boxes are remaining. So there is B1 and there is B3. 2 boxes are remaining. In these boxes we have to put the blue balls. Okay, in these boxes. But remember, this B1 has the capacity of at most 3. B3 has the capacity of at most 5. So how many people they can accommodate? How many people they can accommodate? These two, if you fill them completely, if you fill these boxes completely, then eight people they can accommodate. 8 blue balls you can put. 8 blue balls you can put. So where will the remaining ball will go? Tell me, where that extra one blue ball is there? Where is that extra blue ball? Remember, B1 has capacity of 3, B3 has capacity of 5. If you fill them completely, if you fill this box completely, fill this box completely, then 8 blue balls you can accommodate. Total 8 blue balls you can put. So, but still, one blue ball, where that will go? That will go to B2, because B2 has the capacity of 4. B2 has the capacity of 4, and you are giving 3 balls to B2. So one blue ball will go here. I can say one blue ball will go here. One blue ball will go here. Correct? So this will happen that one blue ball will go to B2. Okay? And remember, 3 will go to B1 and 5 will go to B3. Okay? Yes or no? So the answer will be what? You select which ball will go to B2. From the 9 ball, you select which ball will go to B2. Which ball will go to B2. From the remaining, you select 3 which will go to B1. And the remaining balls will go to B3. And the remaining balls, okay, the remaining balls will go to B3. So the answer will be, in this case 2, what is the answer? Tell me. This is the answer in case 2. This is the answer for case 2. This is the case 2 answer. Now let's see case number 3. Case number 3, what is that? Case number 3 means these 3 red balls, these are going to B3. Remember, B3 has the capacity of 5. B3 has the capacity of 5. In this B3, you can put at most 5 people you can put. And you can notice the remaining blue balls. Okay, the remaining, all the blue balls, where should they go? They should go to B1, B2. But you can notice B1 has the capacity of 3. B2 has the capacity of 4. So how many balls they can accommodate? If you completely fill this box, 7 balls, 7 blue balls they can accommodate. 7 blue balls they can accommodate. If you fill this, if you fill this box completely, then 7 blue balls you can put here. Where are the remaining 2 balls? Where are the remaining 2 balls? 2 blue balls. Where are the remaining 2 blue balls? They will go to B3, because B3 has the capacity of 5. B3 has the capacity of 5. So 2 blue balls will go to B3. Yes or no? 2 blue balls will go to B3 because B3 has the capacity of 5. In this B3 you can put at most 5 people. Okay, already 3 people we are putting, and I can put 2 more people I can put, because remember, B1, B2 does not have capacity. B1 capacity is 3, B2 capacity is at most 4. So if you fill them completely, then only 7 blue balls you can put. But total we have 9 blue balls. So the remaining 2 blue balls will go to B3. So finally, this is the conclusion, that I can say 2 blue balls. I can say 2 blue balls will go to B3. I can say 3 blue balls will go to B1. And I can say 4 blue balls, they will go to B2. So tell me what will happen, what will be the answer? So you can notice, from 9 you can select 2. There are 9 blue balls. From the 9 blue balls, you can select 2. You can give to B3. Okay. From the remaining, you can select 3 and you can give to B1. And the remaining automatically will go to B2. And the remaining will automatically go to B2. Okay, this is your answer for case 3. So what is the answer? Finally, the final answer, what that will be? The final answer will be case 1 plus case 2 plus case 3. Case 1 plus case 2 plus case 3. The final answer will be this. What is the answer for case 1? That I think that is 9C4. Okay, this is the answer for case 1. What is the answer for case 2? The answer for case 2, that is 9 into 8C3. That is 9 into 8C3. And what is the answer for case 3? That is 9C2 multiplied by 7C3. Okay, so you can add them. That will be your answer. Did you understand? Please tell me. This is a nice question. You can notice everything is working very perfectly. Yes or no? In all the cases, everything is working very perfectly. In all the cases, three cases are possible, because these red balls, they should go in the same box. Remember, all the red balls should go to the same box. So you can put them in box B1, or you can put them in box B2, or you can put them in box B3. Okay, so there are three cases. These are the three cases possible. These all the red balls, all these red balls, they should go to the same box. So there are three cases possible. In all the three cases, everything is working very perfectly. In all the three cases, all the boxes are completely filled. So your answer will be this. Let's see this question. This is question from generating function, and this is actually very simple question. This is not a complicated question. This is extremely simple question. Did you solve it? Did you solve this question? We want to find gx equal to bx into fx. This first we have to find gx. See what is given to you. Please see what is given to you. It is given that this bx is given to you. This generating function bx is given to you. Okay, this generating function bx is given to you. That is summation. N is going from 0 to infinity. N is going from 0 to infinity and 2 power n x power n. So this bx is given to you. What is this bx? If you open this, then you will get 2 power 0 x power 0, 2 power 1 x power 1, 2 power 2 x power 2, and so on and so on. This is your bx. Next, fx is given to you. What is fx? Fx is summation n equal to 0 to infinity fn x power n. And what is fn? This is Fibonacci number. So what is fn? This is given to you. What is fn? So you can calculate fn from this. From this recurrence relation, you can calculate fn. So what will be fn? So tell me, what will be the series? Tell me, what will be this series? Fibonacci series. What will be this series? This series will be, the first number is 0, f0 is 0, f1 is 1, then f2 will be summation of these two. f2 will be f1 plus f0. f2 will be f1 plus f0. So that will be 1. Next, f3 will be f2 plus f1. So that will be 2. Next number will be summation of these two. That will be 3. Next number will be summation of these two. That will be 5. Next number will be summation of these two. That will be 8. Next number will be summation of these two. That will be 13, and so on. This is fn. This is a fn. Okay. Now you can notice. So here, what will be this function? So this will be, I can say f0 multiplied by x power 0. I can say this will be f0 multiplied by x power 0, f1 multiplied by x power 1, f2 multiplied by x power 2, and so on. So it will be what? f0 is 0. f0 is 0. So it will be, ultimately f1 is 1. So it will be x plus x square, because this is the series 0 1 1, x plus x square. Then you have 2x cube, and then you have 3x power 4, and so on. This is the fn. This is the fn, fx. Okay. C programming solutions will be discussed tomorrow. We will discuss C programming scholarship test solutions tomorrow. Now let's see this one. So this is your fx. So these two are there. Now what is gx? We are defining gx equal to bx into fx. This gx, we are defining gx equal to bx multiplied by fx. Bx multiplied by fx. Okay. So this gx is what? Let me tell you this gx. This is multiplication of bx into fx. What is bx? That is 2 power 0, which is 1. Okay, that is 2 power 0, which is 1. So 2 power 0 x power 0. 2 power 0 x power 0, that is 1. Okay, so 2 power 0 x power 0, that is 1. 2 power 1 x power 1. 2 power 2 x power 2. 2 power 3 x power 3. 2 power 4 x power 4. 2 power 5 x power 5. And so on. This is your bx multiplied by, this is your bx multiplied by fx. And what is fx? You can notice fx is x plus x square plus 2x cube plus 3x power 4. 3x power 4 plus what will be next? 5x power 5 plus, and so on. And what the question is asking? So this is the gx. Gx is this multiplied by this. Means this multiplied by this This is your gx. So what is gx? Gx means this multiplied by this, this multiplied by this, this multiplied by this. Now what the question is asking? Coefficient of x power 5 in gx. Coefficient of x power 5 we need to find. So how will you get x power 5 here? We want coefficient of x power 5. This coefficient of x power 5 we want in this gx, in gx, in gx. So how will you get x power 5? When you multiply these two, how will you get x power 5? Tell me. When you multiply them, how can you get x power 5? How can you get x power 5? See, when you multiply this with this, then you will get x power 5. Agree? Agree or not? So when you multiply this with this, you will get x power 5. So you will get 5x power 5 plus when you multiply this with this, you will get x power 5. So that will be 6x power 5. Next, when you multiply this with this, you will get x power 5. So that will be 2 power 3 x power 5. Next, what will be next? When you multiply this with this, then you will get x power 5, 2 power 3 x power 5. Next, what is the next? Tell me. So the next is when you multiply this with this, then you will get x power 5, 2 power 4 x power 5. Can you create x power 5 in any other way? Can you create any other x power 5? Can you create any other x power 5? No, you cannot create. No, you cannot create, because if you multiply this with any of them, you cannot create x power 5. So this is what your x power 5, this is how you can create x power 5. So now tell me the coefficient of x power 5. So the coefficient of x power 5, that will be, so the coefficient of x power 5, that will be 43 x power 5. 43 x power 5. Answer will be 43. Okay, and the answer will be 43. Isn't it simple question? Please tell me. This question is very simple question. Two generative functions are given to you. These are the generative functions. This is a very simple question. This generative function is given to you. 2 power n x power n. This is given to you. 2 power n x power n. Look at this. N going from 0 to infinity, 2 power n x power n. So you can notice that 2 power 0 x power 0, 2 power 1 x power 1, 2 power 2 x power 2, and so on. This is your bx. This is the generative function bx. The next generative function is fx, that is f0 x power 0, f1 x power 1, f2 x power 2, and so on. Now this is a Fibonacci series. This is the Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, and so on. What we have to do? We have to multiply them. Gx is equal to bx multiplied by fx. So we have to multiply them. So when you multiply them, then how can you create x power 5? You have to focus on x power 5. So if you want to create x power 5, then you can create like this. When you multiply this with this, you will get x power 5. When you multiply this with this, you will get x power 5. When you multiply this with this, you will get x power 5. Multiply this with this, get x power 5. Multiply this with this, get x power 5. So the answer will be 43. So this is a simple question. This is an easy question, very easy question. Let's see this question. What is the answer? Please tell me. Strongly connected component definition is given to you. This is nothing but the definition. This is just a definition of strongly connected component we have already seen. This is just the definition of strongly connected component definition. So the definition is given to you for the strongly connected component. Now the question is asking on adding one extra edge. In a graph, there is a directed graph. In a directed graph, if you add one extra edge you add in this directed graph, the number of strongly connected component, can it increase? If you add one extra edge, the number of strongly connected component, can it increase? The number of strongly connected component, can it increase? For example, in this graph, how many strongly connected components are there? Please tell me. A, B, C. How many strongly connected components are there? Tell me number of strongly connected components. What is that? How many strongly connected component in this graph? Total 3. Because you can note this is a strongly connected component, this is a strongly connected component, and this is a strongly connected component. So total strongly connected component is 3. In this graph, 3 strongly connected component are there. Remember, this is not a strongly connected component. Please understand that this is not a strongly connected component, because you can notice that we can go from B to C. There is path from B to C, but there is no path from C to B. So this is not a strongly connected component. This is not a strongly connected component because we have path from B to C, but there is no path from C to B. Okay, so in this graph you have three strongly connected component. Tell me in this graph how many strongly connected component are there? C. Now in this graph how many strongly connected component we have? Tell me. In this graph, like in this graph, how many strongly connected component? So there are two strongly connected component. There are two. One strongly connected component is this, and another strongly connected component is this. So two strongly connected component you have in this graph. Now the question is saying that you have a graph. In that graph, if you add one extra edge, if I add one extra edge, can I increase the number of strongly connected component? Just think about it. Just think about it. Let's assume this is your graph. A, B, C, D, E. How many strongly connected component? Tell me in this graph. How many strongly connected component? In this graph, how many strongly connected component we have? Tell me. What is the total number of strongly connected component in this graph? Answer is very simple. What is that? Okay, this is a strongly connected component. This is another strongly connected component. Okay, this is another strongly connected component. And this is another strongly connected component. So total three strongly connected component you have. Correct? Very simple. You can notice here every vertex is reachable from every vertex. In this is a strongly connected component. This is a strongly connected component because every vertex is reachable from every other vertex. Here you can notice that this is not a strongly connected component. If you do like this is not a strongly connected component because there is no path from E to D. Okay. Now if I add one edge, for example, if I add one edge, then can I increase? Remember, this is your strongly connected component. Now if I add one edge, if I add this edge, if I add one edge, like if I add this edge, then what will be the number of strongly connected component? If I add this edge, like this DE, this edge I add, sorry, this ED, this edge I add, then now what is the number of strongly connected component? Now that is 2. So it can decrease by 1. I can say it can decrease by 1. When you add one edge, this edge I am adding, so it can decrease by 1. If I add this edge, okay, like can it be unchanged? Can it be unchanged? If I add this edge, then what will be the number of strongly connected component? If I add this edge, now strongly connected component are 3. Strongly connected component will not change. This is the strongly connected component, this is the strongly connected component, and this is the strongly connected component. So that is not changing. So you can notice when you add one edge, may remain unchanged. This is correct? Yes or no? Agree? This is correct. May remain unchanged. May remain unchanged. Like you can notice here. But can it decrease? It can decrease by 1. It can decrease by 1. I can say when you add edge, so okay, when you add edge, then strongly connected component can decrease by 1. Number of strongly connected component can decrease by 1. Can decrease by 1. It cannot increase. Agree? It cannot increase. Definitely it cannot increase. Either it will remain the same, or it will either it will remain the same, or it will decrease. It cannot increase. It cannot increase. Now can it decrease by more than 1? Can it decrease by more than 1? Can it decrease by more than 1? See, if I add this edge, look at this. If I add this edge, now what will be the number of strongly connected component? If I add this edge, I am adding one edge. This edge I am adding. Now what is the number of strongly connected component? If I add this edge, now the number of strongly connected component will be 1. So number of strongly connected component can decrease by any number. If you add one edge, number of strongly connected component can decrease by any number. Like it can decrease by 2. It can decrease by any number. Another example, very very simple example. In this, how many strongly connected components are there? C, D, E, F. How many strongly connected component are there? Please tell me. In this, what is the number of strongly connected component? What is the number of strongly connected component in this? So total that is 6. Number of strongly connected component is 6. Every vertex is a strongly connected component. Okay, every vertex is a strongly connected component. Every vertex is a strongly connected component in this graph. In this graph, you can notice every vertex is a strongly connected component. Now, if I add this edge, then what will happen? Please tell me. If I add this edge, now what will happen? I am adding one edge. So you can notice number of strongly connected component was 6. If I add one edge, if I add this edge, FA, if I add this edge, now the number of strongly connected component that will become only 1. It can decrease by any number, yes or no? You are adding one edge, only one edge you are adding, it can decrease by any number. It can decrease, like it can decrease by 5. It can decrease by 5. It was 6, it has become 1. It can decrease by 5. If I add this edge, then it will decrease by how much? Like if I add this edge, then now the number of strongly connected component, it was 6. If I add this edge, FB, then number of strongly connected component will be 2. It will be 2. So it can decrease by 4. It can decrease by 5. It can decrease by 4. It can decrease by any number. Agree or not? It can decrease by any number. Whatever number you want, it can decrease by any number. Or it may remain unchanged. If I add this edge, then it will remain unchanged. Number of strongly connected component was 6. If I add this edge, CF, then number of strongly connected component will be same. Unchanged. Unchanged. So this is a very nice question, yes or no? So very nice question, that it cannot decrease by more than 1. No. It cannot decrease by more than 2. No. It can decrease by any number. Okay. It can decrease. It cannot increase. It cannot increase, but it can decrease by any number. Let's see this question. What is the answer for this? In this graph, everything you are asked. Okay. We are asking everything. Like in this graph, find everything. Find chromatic number, matching number, everything. Find matching number, find chromatic number, find independence number, clique number, vertex cover number, and edge cover number. Everything we have to find. So let me tell you two methods. Let me tell you method number 1. Let me tell you method number 1. What is the method number 1? The method number 1 is find this. First of all, what is this graph? When you look at this graph, what will come to your mind? This is a standard graph. Have you seen this graph? Have you seen this graph? This is a standard graph. What is this graph? This is your Q3. This is your Q3, means hypercube graph on 8 vertices. This is your hypercube graph. This graph is your hypercube graph. This graph, if you notice, this is a hypercube graph. This graph is like this. Okay, this graph is something like this. Look at this graph. This graph is something like this. So this is a hypercube graph. This graph. Okay, correct? Yes or no? Okay. So this is a hypercube graph. This is your Q3. This is your hypercube graph. And hypercube graph is bipartite. Can I say hypercube graph is bipartite? Whenever you see hypercube graph, I told you this in the class. I told you that whenever you see hypercube graph, any question of hypercube graph, if you see any question of hypercube graph, then what should come to your mind? Whenever you see any question of hypercube graph, what should come to your mind? That it is bipartite. That it is bipartite. Okay, it is bipartite. Now you can find very easily. So this is your hypercube graph. And so what is the chromatic number? Let's find out the chromatic number. So basically this is bipartite graph. What is the chromatic number of bipartite graph? What is the chromatic number of bipartite graph? That is at most 2. But here you have at least one edge. Here you have at least one edge. There is at least one edge. And this is bipartite. So the chromatic number bipartite with at least one edge. Okay, so bipartite. This is a bipartite graph with how many edges are there? You can notice how many edges are there. Okay, 4, 4, and so total 12 edges are there with 12 edges. So you can notice that this chromatic number will be the chromatic number that will be 2. Next, what will be the okay, in this, what will be the independence number? What will be the independence number? Independence number. This is a bipartite graph. this is a bipartite graph. There are 4 vertices here. There are 4 vertices here. This is a bipartite graph. There are 4 vertices here, and this type of bipartite graph you have. So what is the independence number? You can notice this is the independent set. This is the independent set. This is the independent set. So the independence number alpha, that will be 4. Okay. Next, what is the what is the clique number? What is the clique number? What is the maximum? What is the maximum size complete subgraph? What is the clique number? Omega. What is the clique number? Omega. That is the maximum size complete subgraph. That will be 2. Because this is a bipartite graph. In a bipartite graph, you already know this. We have already seen that in a bipartite graph, you don't have, in a bipartite graph, you don't have, there is no subgraph K3, or there is no subgraph. There is no complete subgraph of size more than equal to 3. There is no complete subgraph, because in a bipartite graph you cannot have odd cycle. You cannot have triangle. If you cannot have triangle, then it means you cannot have complete subgraph also. Agree or not? In a bipartite graph, you cannot have, in a bipartite graph there is no odd cycle. There is no odd cycle. It means there is no triangle. It means there is no triangle, and it means there is no complete subgraph. There is no complete subgraph of size greater than equal to 3. Okay, so I can say that the maximum size complete subgraph will be 2. Okay, the maximum size complete subgraph, that will be 2. Next, this is your clique. This is the clique number. Next, after that, fourth, what is the vertex cover number? What is the vertex cover number? Tell me, what is the vertex cover number? That is beta. What is the vertex cover number? If you want to cover all the edges in a, this is your bipartite graph. This is your bipartite graph. If you want to cover all the edges, 4 vertices are here, 4 vertices here. If you want to, the edges are like this. If you want to cover all the edges, then this will be your vertex cover. So what will be your vertex cover size? That will be 4. I can say this is your vertex cover. Next, after that, what is the edge cover? If you want to cover all the vertices, I want to cover all the vertices. So if you want to cover all the vertices, then what is the edge cover? You can notice this is your graph. This is your graph. In this graph, what will be the edge cover? So let me write the edge cover. This is the edge cover. Edge cover means you have to cover all the vertices. So I can take this edge, these 2 vertices covered, these 2 vertices covered, these 2 vertices covered, these 2 vertices covered. So the edge cover number will be what? That will be 4. This. If I take, then edge cover number, this is a edge cover, I can say. So finally, edge cover number, that will be also 4. And what will be matching? What will be matching number? What will be matching number? This is also matching also. If you notice, this is matching also. If you notice, this is edge cover also, and this is matching also. I can say this is matching also, because if you have this graph, this is the graph. In this graph, you can clearly see that this is matching also. This edge you can take, this edge you can take. So okay, this is matching also. So we have seen everything. So finally answer will be what? So we have seen matching number. Matching number is 4. Chromatic number is 2. Independence number is 4. Clique number is 2. Vertex number is 4. And edge cover number is 4. So finally answer is what? Tell me your final answer. What will be the final answer? The final answer will be, if you add all of them, that will be 20. So the answer is 20. Okay. But tell me, actually, this is the method number 1. But you can solve this question quickly. Actually, you don't need to do this. You can solve this question very quickly. This is method number 1. You can solve this question actually very quickly. You don't need to calculate all of them. You don't need to calculate all of them. For example, this is my question. See, please understand this question. Let me give you a graph. Okay, if I give you a graph, let's assume some random graph I am giving you. Okay, some complicated random graph I am giving to you. D, E, F. Okay, some random complicated graph I am giving you. G, H, I. Okay, so maybe something like this. Maybe something like this. Now, this graph. Now, if I ask you find the independent set, how much time it will take? If I ask you, okay, find independent set. Basically, if I ask you what will be alpha plus beta, what will be alpha plus beta for this? What will be alpha plus beta for this? Means independence number plus vertex cover number. For this graph, if I ask you what is independence number, basically I ask you independence number plus vertex cover number, plus vertex cover number. If I ask you, will you find the independent set in this? Will you find the independent set? If I ask you this, I ask you independence number plus vertex cover number. If I ask you this is the question. This is the question. What is the independence number plus vertex cover number? Will you find independence number in this? Will you find? Tell me. Will you find independence number in this? No, because it will take a lot of time. It will take a lot of time. If you find independence number in this, it will take a lot of time. If you find vertex cover number in this, it will take a lot of time. But the question is asking independence number plus vertex cover number. You don't have to find them separately. Don't find separately. There is no need to find separately. There is no need to find them separately. There is no need to find them separately, because you know that alpha plus beta, independence number plus vertex cover number, that is equal to number of vertices. This we already know. We also know that matching number plus edge cover number, that is also number of vertices. These two results we know. What I'm saying, we already know that independence number plus vertex cover number, independence number plus vertex cover number, that is equal to number of vertices. We also know that matching number. We have already seen the proof. Yes or no? Do you remember the proof? Do you remember the proof of this? Anyone? Arpan, Yuvraj, do you remember the proof of this? A meme I created. We have already seen the proof, and also I created a meme also on this. That was a Hera Fairy meme, if you remember, Hera Fairy meme. So if you remove the independent set, then you will get vertex cover. If you remove the vertex cover, then you will get independent set. Okay. So from the graph, if you remove independent set, then you will get a vertex cover. If you remove vertex cover, then you will get independent set. Okay. Similarly, matching number plus edge cover number, that is also number of vertices is equal to n. Okay. So finally, this is the idea. So you don't have to calculate. You know that will be number of vertices. So for this question, what will be the answer? The answer will be just find the number of vertices. That will be total 9. Just find number of vertices. Okay. Now similarly in this question, let's see the method number 2. In this question, what I am asking? In this question, I am asking independent set plus vertex cover number plus matching number. Basically, this is what I am asking. In this question, I am asking independence number plus vertex cover number. Okay. Plus matching number plus edge cover number. Okay. Matching number plus edge cover number. Okay. Now you can notice this is equal to total number of vertices. This is equal to total number of vertices plus basically the chromatic number you have to find, that will be 2, and you have to find the clique number, that will be 2. So the answer will be 20. So you can do this question very easily if you do this. Okay, this is your method number 2, and this method number 2, this is suggested by Amar. Okay, so let me give you that this credit goes to Amar for suggesting this. Amar suggested on GATEOverflow. On GATEOverflow website, you can check it out. Amar has suggested this method. This is a very nice method. It will save you a lot of time. On GATEOverflow website, Amar has suggested this method. Very nice method. Okay, so that's it. Now, so let's solve this. So 5 questions are remaining. I think this is enough for today. The remaining questions I will discuss in the next session. Okay. So we have seen total I think total 8 questions we have seen, and some questions are remaining. Total 9 questions we have seen. Some questions are remaining. 4 questions are remaining. So we have already seen 9 questions. Okay, 9 questions we have already seen, and total 4 questions are remaining. These 4 questions we will see after some time. Okay, we will see day after tomorrow. Okay, we will see day after tomorrow, or I can tell you the date. So these remaining questions we will see on the 9th August. On the 9th of August we will see these. Okay, so on the YouTube channel, on the Go Classes YouTube channel, we will have next session. These questions we will see in the next session. Some nice questions are there. Okay, and if you want to access all these questions, see all these questions, if you want to access, then the link you can find in the description. You can go to GATEOverflow website and you can find all these questions. The link is already in the description for all these questions, for all these 13 questions. Okay, for all these 13 questions, the link is in the description. So if you want to find out the questions, then you can check out the link. The link is in the description. Okay, so tell me, so all these questions, like, did you like them? All these questions that we have seen, did you understand everything? Remember, the analysis is more important. How much marks you are getting, that is not important. What is important, that is analysis. Did you understand all these things? On the Go Classes YouTube channel, you can see this playlist. This recurrence relation playlist you can see on the Go Classes YouTube channel. On the Go Classes YouTube channel, you can see this playlist, recurrence relation in discrete mathematics. Okay, so this playlist you can watch. In this playlist, total 8 videos are there, and this playlist will definitely, it will improve your knowledge of recurrence relation. So watch this playlist on the Go Classes YouTube channel. And remember, complete discrete mathematics and C programming courses by Go Classes is freely available for all the learners. Please remember, complete courses. I'm not saying that only few things. No, complete courses. Remember, complete discrete mathematics, C programming. These two courses, complete discrete mathematics and C programming courses, these are free. Okay, Go Classes complete discrete mathematics C programming courses, these are free for all. These are free for all learners. Anyone who want to learn these two subjects, okay, then you can watch. You can go to Go Classes website. Just go to www.goclasses.in. There you will find these courses you will find. Okay, and these are freely available for all the learners. The complete courses means the lectures, the lecture notes, homework, quizzes, everything. Okay, and also let me tell you a very interesting thing that I already told you in the last session. Last year, the scholarship test, like basically last year, I can say last year scholarship test, last year Go Classes scholarship test. These are the toppers of last year Go Classes scholarship test. These are the toppers of Go Classes last year Go Classes scholarship test. And let me tell you, all these toppers are at very brilliant locations. I can say all these toppers are in the great places at this time. Like Amay is in ISI. Others is in 4th year. So right now he is preparing. He is in 4th year. But Narayana, he is in IIT Madras. Sarvesh is in IIT Hyderabad. Okay, Sarvesh is in IIT Hyderabad. Akshay is in IIT Hyderabad. Abhishek, he is in IISc. He is in IISc. Dipankar is in IIIT Allahabad. IIIT Allahabad. And other toppers, Mayank is in IIT Kanpur. Neelam is in Bark. Likhit is in IISc. Okay, and Aditya got all India rank 700 and he is in final year. So he is still he is in final year, so he is preparing, but he got all India 700, all India rank 700. So you can notice last year Go Classes scholarship test toppers. Can you notice they are in very brilliant institutes? ISI, IIIT Allahabad, I can say IIT Madras, IIT Hyderabad, ISC Bangalore. Likhit is all India rank 82. He is in ISC Bangalore. Okay. So anyway, also let me tell you that please understand that marks is not important. What is important? Analysis is important. So after the test, once you attempt a test, after the test, analysis, learning is important. Don't get demotivated by low marks. because remember here toppers are there. So toppers, they don't care about marks. Okay, so toppers, they only care about constant improvement, constant learning. Okay, so these are the toppers. So don't worry about marks. This is the statement by Jaskaran Singh. So if you want a good quality test series, if you want to attempt some good quality questions, some good quality test, if you want to attempt, then you should go for goclass and GATEOverflow test series. So you can enroll in this goclass GATEOverflow test series if you want to solve some good quality questions. Okay, so goclass and GATEOverflow, this test series, GATEOverflow plus goclass, this combined test series, you can take. In this combined test series, there are more than 100 tests, there are 15 mock tests, there are more than 4,000 quality questions. Almost 4,000 quality questions are there in this test series. Okay, so if you want to solve some quality questions, some good quality questions, if you want to improve your understanding, if you want to improve your problem solving skills, okay, if you want to increase your chances of cracking the GATE exam, then you can enroll in the goclass test series. And this is our GATE CSE 2023 complete course. In this complete course, you have everything. You have weekly quizzes, you have homework, you have GATE video solutions, you have doubt resolution support on the Telegram. Okay, so everything you have in this, and quality learning, everything that we teach by with ideas, with proof. So in goclass, you will never by heart anything. Okay, if you want to learn, then you can go for goclass GATE 2023 complete course. If you want to prepare for GATE 2024, then also you can visit goclass website. If you are preparing for GATE 2024, then just go to our goclass website. There you will find GATE 2024 course. Okay, GATE 2024 course also you will find on the goclass website. And also we have Android app. Okay, goclass Android app you can download. So on the Play Store, you can go and you can write goclass. Okay, just write goclass and you can find the Android app, and this app also you can use. You can use this app to watch our lectures. Okay, all the goclass lectures you can watch on the Android app. Just go to the Play Store and you search for goclass and you will find this app. You can download. The link is in the description. Link of everything is in the description. You can join our Telegram group. If you have any doubt discussion, then you can join our Telegram group. Okay, and and you can subscribe to our YouTube channel. So link of everything, please understand that link of everything is in the description. Link of test series, link of complete course, link of Telegram group, link of I can say link of these questions, these scholarship test questions, link of the application, our Android application, link of everything you will find in the description. So just check out the description, you will find everything. You can join our Telegram group, you can download our Android app, and you can watch our free lectures, free courses. Discrete mathematics and C programming complete courses are freely available for all the learners. Okay, so you can watch our free courses. 2 courses are freely available for all the learners. Now let me tell you one more thing. This scholarship test, if you get a scholarship, then that is very good. Okay, but if you don't get a scholarship, then don't worry about it, because remember, GATE exam is more important than scholarship. Please understand that your GATE rank, your GATE exam, your GATE result, please understand your GATE result, GATE preparation, that is much more important than scholarship test. Then that is much more important than any test. Okay, so remember, our ultimate target is GATE result, our ultimate target is GATE rank. We want to go to IIT, ISC, we want to go to PSU. Okay, we want to go to top colleges like IIIT Hyderabad, IIIT Bangalore, NITs, top NITs. Okay, this is what we want to do. So remember, your GATE result, your GATE preparation is much more important than any test, any scholarship test, any test series. So what I'm saying, that if you get a scholarship, then very good. But if you do not get a scholarship, then also you can join our GATE 2023 complete course. Okay, you can join our GATE 2023 complete course, because ultimately cracking the GATE exam with the top rank is our target. We want to crack GATE exam with the top rank, single digit, double digit, okay, rank we want to get. So if you do not get a scholarship, then also you can join our GATE 2023 complete course. You can join. The fees is very minimal. Okay, we don't have like very high fees. Okay, we don't have very expensive course. The course is very much affordable. It is a very much affordable course. So you can join our GATE 2023 complete course. You can join if you do not get a scholarship, and if you get a scholarship, then very good, congratulations to you. Okay, tomorrow we will announce the results. The scholarship result we will announce tomorrow. Okay, anyone has any doubt, let me know. Please let me know. Anyone has any doubt? Any doubt, anyone? Did you understand all the questions? Total 9 questions we have seen. We have seen total 9 questions. Did you understand all the questions? So all these are very analytical questions, nice questions. Okay. So if you understood all the questions, then very good. If you have any doubt, you can watch the video again. Okay. The remaining questions, the remaining 4 questions I will discuss day after tomorrow. Okay. So on the 9th August, we will discuss the remaining questions. Okay. Thank you everyone. Thank you so much.